Okay, good day, class. Welcome back to Teach and Learn channel. Today, we'll be discussing another new lesson in Earth and Life Science. Our focus for this lesson is about geological hazards. Namely, we will be discussing what is an earthquake, volcanic eruption, and landslide. The following learning competencies for this lesson are the following. Number 1, describe the various hazards that may happen in the event of earthquakes, volcanic eruptions, and landslides. Using hazard maps, identify areas prone to hazards brought about by earthquakes, volcanic eruptions, and landslides. And the last one, identify human activities that speed up or trigger landslides. Let's start it with an earthquake. What is an earthquake? An earthquake is shaking and vibration at the Earth's surface of the Earth. It is a sudden tremor or the sudden shaking of the ground that is due to the released seismic waves or energy of an earthquake. Have you ever experienced earthquake before? How do you deal with an earthquake? Aside from knowing that earthquake is the sudden shaking or sudden shifting of the ground, earthquake could also be categorized into two. We have minor earthquake that is caused by explosion, which is examples are the volcanic eruption. We also have major earthquake, but this time is caused by the movement of the tectonic plates. Whether it is a minor earthquake or major earthquake, every one of us should be prepared at all times. Minor earthquakes are usually caused by the volcanic activities. A volcano is considered active. It produces if the volcano releases a volcanic activities such as minor earthquakes. This is the earthquake diagram. We have the focus, the epicenter, and we have the surface rupture. Let's start it with the focus. Focus or hypocenter is a point where energy is originated. The focus is the point underground where rocks first began to move. Seismic waves travels outward from the earthquake's focus. Epicenter, on the other hand, is the point on the Earth's surface directly above the focus of an earthquake. Earthquake's energy is released in seismic waves. These waves spread out from the focus. The waves are felt most strongly at the epicenter, becoming less strong as they travel further away. The most severe damage caused by an earthquake will happen close to the epicenter. On the other hand, this is the fault line and the surface rupture. Fault or fault line is a line determined by the intersection of a geological fault at the Earth's surface. In the study of earthquake, one thing to remember about is the magnitude and intensity. When we say magnitude, it refers to the energy released by an earthquake at the focus. It is calculated from the earthquakes recorded by an instrument called seismograph. While when we say intensity, it is the strength of an earthquake perceived and felt by people in a certain locality. Intensity is generally higher near the epicenter. Take note that from the previous slide, we discussed about the parts of an earthquake. We have the focus. It is the point wherein the earthquake is originated or the energy is released. The energy released by an earthquake is measured by a magnitude or by instrument called seismograph or seismometer. While when we say intensity on the other hand, it refers to the damage done by an earthquake. Magnitude and intensity have follows the scaling system. For magnitude, we are using Richter scale. Magnitude 1, 2, 3, 4, 5, 6, 7, and 8. Then for intensity, we are using Mercalli intensity scale. Roman numeral 1 up to Roman numeral 12. 12 is the highest and 1 is the lowest. And so with the magnitude, for Richter scale, 8 is the strongest earthquake while 1 is the lowest. Each scaling system has different interpretation. We have instrumental, feeble, slight, moderate, rather strong, strong, very strong, destructive, ruinous, disastrous, very disastrous, and the last is catastrophic. Now, does earthquake always do harm on us? Upon learning that magnitude refers to the energy release of an earthquake, does earthquake always do harm on us? The answer is no. It's not yes and it's not maybe, but the answer is no. Why not? Because earthquake must be strong enough for it to be destructive by nature. Of course, earthquake is destructive by nature, but earthquake varies depending on the energy release or simply the magnitude. Once a magnitude is considered as small quakes or minor earthquakes, it doesn't cause harm to people or to every living organisms. One thing to study about the earthquake is the earthquake-related hazards. Of course, in your previous science classes, you are already aware or your previous science teachers already discussed what are the different earthquake or what is an earthquake. But this time, we will be discussing the different earthquake-related hazards. Namely, we have ground shaking, ground rupture, liquefaction, earthquake-induced landslide, and tsunami. Let's start it with a ground shaking. Ground shaking is a disruptive up, down, and sideways vibration of the ground during an earthquake. As we have defined a while back, earthquake is the sudden shifting of the ground. That sudden shifting of the ground simply means the ground shaking. Now, what are the effects of ground shaking? Ground shaking can cause damage or collapse of structure or infrastructures. Note that it is due to inferior design, poor construction, or weak foundation that cause people harm or death. The second hazard brought by earthquake is the ground rupture. Ground rupture is a deformation on the ground that marks the intersection of the fault with the Earth's surface. Here, during strong earthquakes, faulting may reach the Earth's surface as ground ruptures. As you have seen from the pictures, the road will break or tear apart because of the energy released during an earthquake or just simply because of an earthquake. This became hazard to every living organisms, including humans and animals, because of this tremor or because of this destruction brought by an earthquake. The third hazard related to earthquake is the liquefaction. Liquefaction refers to the phenomenon wherein sediments, especially near bodies of water, behave like liquid similar to a quicksand. Ground shaking and vibrations during an earthquake rearranges sand particles. Water is released and causes the sediment grains to separate as they are pushed apart. The sediments become more mobile and attain a jelly-like consistency. From a solid state, the sediments are transformed into a liquefied state due to increase in pore water pressure. It is important to remember that an earthquake must be strong enough to liquefy susceptible sediments. The fourth hazard related to earthquake is the earthquake-induced landslide. Basically, this is a downslope movement of rocks, solid, and other debris commonly triggered by strong shaking. The landslide that we are all familiar about is actually induced by a strong typhoon. But this time, when we say earthquake-induced landslide, it is a landslide caused by the strong shaking of the ground or simply by the energy released during an earthquake. It is triggered by the strong shaking or by an earthquake per se. The last earthquake-related hazard is a tsunami. Tsunami is a series of waves caused commonly by an earthquake under the sea. Tsunamis are giant waves caused by earthquakes or volcanic eruptions under the sea. Out in the depths of the ocean, tsunami waves do not dramatically increase in height, but as the waves travel inland, they build up to higher and higher heights as the depth of the ocean decreases. These are the following causes of tsunami. From the data gathered, 75% of tsunami are caused by an earthquake or simply a seaquake. Tsunamis can be secondary effects of earthquakes occurring under the ocean or in coastal areas. 5% of tsunami are caused by volcanic eruptions or volcanic explosion. Any submarine or coastal volcanic activity and products that can trigger tsunami by displacing large volumes of water. 8% of tsunami are caused by landslide, underwater and land-based. 10% are unknown causes, while 2% cause of tsunami are brought by meteorite impact in the ocean. Meteorites impacting the ocean can trigger tsunamis. Let's now move with the second geologic hazard, which is the landslide. Landslide is the mass movement of rock, soil, and debris down a slope due to gravity. This is what we call mass wasting. Landslide materials may include soil, debris, rock, and garbages. Landslides are commonly occurring in mountain ranges or in higher areas. Landslides, as we have all known, are caused by different natural disasters and even anthropogenic activities. So, what are the different causes of a landslide? Landslide can be triggered by a certain geologic conditions and hazards such as typhoon, earthquake, and volcanic eruptions. An earthquake loosens the soil and causes cracks on the rocks that eventually fall off. Like what we have discussed a while back, one of the earthquake related hazards is the earthquake-induced landslide. This is a landslide triggered by the strong shaking. Aside from earthquake, landslide may be triggered by a typhoon or intense rainfall. Intense rainfall, landslides are triggered due to the weakening of the slope material by water saturation. And also, we have volcanic eruptions. But aside from these geological conditions or natural disasters, human activities may also lead to landslide or could also hasten the occurrence of landslide. Such activities are the following. We have mining, deforestation, and construction of houses and building. As we have all familiar, in mining, a landslide occurs in mining once the foundations become weak. And so with the deforestation, as we are all familiar with, trees are responsible for capturing or for absorbing water from the ground. So once the deforestation continues, the water from the ground become more and more, the liquefaction happens, and therefore causing the soil or the soil from the ground become more susceptible to landslide. So these are just some of the human activities that could trigger or that could hasten the occurrence of landslide. The third geologic hazard that we will discuss throughout this lesson is a volcanic eruption. Volcano is an opening from the Earth's crust from which pyroclastic materials, lava, and other gases are spewed out. Volcanic eruptions are one of the Earth's most dramatic and violent agents of change. Not only can powerful explosive eruptions drastically alter land and water for tens of kilometers around a volcano, but tiny liquid droplets of sulfuric acid erupted into the stratosphere can change our planet's climate temporarily. Eruptions often force people living near volcanoes to abandon their land and homes, sometimes forever. Those living farther away are likely to avoid complete destruction, but their cities and towns, crops, industrial plants, transportation systems, and electrical grids can still be damaged by tephra, ash, lahars, and flooding. Although volcanic eruptions could be majestic event, but it is destructive by nature. Understanding volcanic hazards can really save lives. So what are the hazards brought about by volcanic eruptions? Before we go on with that, let's first discuss what are the two types of eruptions. We have the first one, effusive eruptions. It is dominated by the flow of lava and formation of fountains and lakes. As we have defined a while back, volcanic eruptions, or volcano, is an opening from the Earth's crust from which pyroclastic materials, lava, and other gases are spewed out. Once a lava is spewed out from the volcano, effusive eruptions are happening. It is dominated by the lava flow. The second type of eruption is explosive eruption. It consists of ash and larger fragments of pyroclastic materials, forming ash clouds and covers the slopes of a volcanic eruption or of a volcano. Among the two, explosive volcanic eruptions can be dangerous and deadly. They can blast out clouds of hot tephra from the side or top of a volcano. Whether it is explosive eruptions or effusive eruptions, both of these could be deadly once a citizen or once the community are not prepared with this natural disaster. So what are the hazards brought by volcanic eruptions? We have the first one, the lava flow. It is a mass of molten rock that flows down the slope of the volcano. As we have defined a while back in the effusive eruption, it is dominated by the lava flow. So this lava flow is actually one of the volcanic eruption hazards. When we say hazards, these are the threat. It brought threat to to the life of a living organism. Could be plants, animals, and of course human. Aside from lava flow, we have pyroclastic flow, which is of course in explosive eruptions. Pyroclastic flow is a mixture of fragmented volcanic particles or pyroclastics, hot gases, and ash that rush down the volcanic slopes or rapidly outward from a source vent at a high speed. Explosive eruption is dangerous or could be dangerous and deadly aside aside from effusive eruption, simply because pyroclastic flow consists of not just a rocks, not just a small fragments of rocks, but of course hot gases and ashes that once we inhale, it could be dangerous to us or it could be dangerous to our respiratory system. Aside from lava flow and pyroclastic flow, we also have ballistic projectiles. These are rocks that are released into the air by an erupting volcano. These rocks are said to be dangerous. Why? Because these rocks are molten. Molten rocks that are released during an erupting volcano. We also have volcanic gas. Volcanic gas is one of the basic components of magma or lava. This volcanic gas could either consist of sulfuric acid or different acids that once we inhale could be dangerous to our respiratory system. We also have lahar. These are hot or cold mixtures of water and volcanic debris that form when volcanic materials interact with water or loose wet sediments. The material flows down from a volcano, typically along river valleys. This is actually what happened in Mount Pinatubo eruptions during the 1991. The eruptions from Mount Pinatubo were dominated not by the lava flow nor a pyroclastic flow, but rather by the lahar flow that could bury different structures. In this case, from the picture, the church were buried down by the lahar that were cooled, solidified, and hardened. Altogether, we discussed three geologic hazards, namely earthquake, volcanic eruptions, and landslide. We also discussed the different hazards brought by these three geologic hazards. Understanding the hazards related to these three are important to save lives. Please do like, comment, share, and subscribe, and click the notification bell for more videos and learnings to come. Thank you!